Hello and welcome to Saras's classes. Today we are going to solve one problem from IIT JAM 2020 Mathematical Statistics. This is a problem numbered 49. Okay, so this is basically a numerical answer type question. In this type of questions, we need to find a numerical answer for the particular question. And here we are told that we need to round off uh, the answer to two decimal places. So let's see what is in this question. Let the sample mean based on a random sample from exponential lambda distribution be 3.7. Then the maximum likelihood estimate of a 1 minus e to the power minus lambda equals to what? Okay. So we are given that x is exponential lambda. Therefore, f of x, the PDF is lambda e to the power minus lambda x, where x is strictly positive. Now the likelihood function is f of x curl or Lx curl is equals to lambda to the power n e to the power minus lambda sum over xi, where xi's are strictly positive. Now the log likelihood ln x curl is n ln lambda minus lambda sum over xi. Okay. Now if we do the derivative with respect to lambda, we get ln L is equals to n by lambda minus sum over xi is, if we equate it to 0, then we get the MLE of lambda, which is nothing but 1 by x bar. Let's check whether the answer is right or not. How can we check this? We just did the double derivative. If we do the double derivative and it results in less than 0, then our answer is true. Okay, so if we do the double derivative, we get minus n by lambda square, which is less than 0. Hence this is the maximum likelihood estimator of lambda. Okay, now we know that MLE follows invariance property. So by invariance property, we know that if lambda hat is the MLE of lambda, then g lambda hat is the MLE of g lambda. Now the g lambda here given as 1 minus e to the power minus lambda. Okay, hence g lambda hat is nothing but 1 minus e to the power minus lambda hat, or e to the power minus 1 by x bar. Now by the question, x bar is 3.7. So 1 minus e to the power minus 1 by 3.7, which results in 0.2366. If we round it to two decimal places, we get 0.24. So 0.24 is our required answer. So we have solved this problem, and that's all for today. Thank you very much.